Hello, welcome to 4F. I've already done my previous videos on charged objects, looking at I equals Q over T, looking at V equals U over Q, which looks similar to the one that you're going to see today, and previous modules for this new year 11 physics course. So please check out those videos, playlists in my channel. If you haven't subscribed, please subscribe. Any feedback's welcome. So let's have a look at 4F. Investigate quantitatively the current voltage relationships in ohmic and non-ohmic resistors to explore the usefulness and limitations of Ohm's law using V equals W over Q and R equals V over I. Now you would have seen V equals U over Q in my previous video, which I did suggest you can substitute U as W as it is work done. Okay, so that equation can occur in both formats. Energy is required to separate positive and negative charges. When charges separate, work is done. When a static charge moves, the potential difference through which it moves is defined as work done per unit positive charge in moving the charge from one point in the electric field to another point in the electric field. So if we're looking at these values that is given in the equation, ohms, volts, and amps, what does that actually mean? You can see that in the diagram there, and it's a typical diagram you may have already seen in junior science. So ohms is resistance, so if you look there, it's the cross-section area in that diagram. Amps is the amount of current, volts is the amount of push on that current. So resistance is affected by cross-sectional area, material of the conductor, temperature of the conductor, and length of the conductor. Ohmic conductors are those that obey Ohm's law, which means that the current flowing through the conductor is directly proportional to the voltage applied across its ends. In ohmic conductors, the resistance of the conductor remains constant, that's key, as the current flowing through it increases. Non-ohmic conductors do not obey Ohm's law. In non-ohmic conductors, the resistance does not stay constant as the current flow increases. Current flow is not directly proportional to the voltage applied. The resistance of a conductor increases if the current flowing through it increases because its temperature rises. Most ohmic conductors are only ohmic within a relatively small range of temperatures. Eventually the temperature will also rise, and this will change the resistance and then become non-ohmic, and you can see that in my diagrams at the bottom here. So let's have a look here at a question. Now, if you like the opportunity to pause it, then do so now. Now, let's have a look here. Distinguish between an ohmic and non-ohmic conductor. So, an ohmic conductor obeys Ohm's law, whereas a non-ohmic does not. Sketch graphs to show the relationship between the current flowing in a non-ohmic and ohmic conductors. You can see that they're given to you. So, current and voltage is proportional in the right diagram in ohmic resistors. Consider the electric circuit as shown. Using your definition of potential difference above in my previous slides, determine the potential difference across these points. So A, B, C, and D. If you'd like the opportunity to pause it, then do so now. Okay, you got a key thing in this diagram that is going to be critical for using Ohm's law's equation. You've got 3 amps in that circle, which is an ammeter, and it's representing how much current is going through this circuit. So you've got 3 amps, so you've got your I, and you've got the resistors in each of those points. So you've got 2 ohms, 4, and 5 ohms. Now you just can rearrange the equation, so V equals IR, times those numbers together, and you'll get between Q and R, so 2 times 3 is 6 volts. R and S is just 4 times 3, which is 12. R and T, now you need to add the resistance, so it's 9 times 3 is 27. Q and T, so 11 times 3 is 33. And P and Q, there's no potential difference, so it's just 0. Okay, so that there is pretty much a summary of Ohm's law, ohmic and non-ohmic resistors. I will address the questions in class in my booklet. So please, if you haven't subscribe, like, dislike, any feedbacks, positive feedback for me to produce my next set of videos for Year 12. Thank you.